Hello, and welcome to Lesson 16.2. We're going to talk today about angle measures and angle bisectors. An angle is a figure formed by two rays with the same endpoint. That common endpoint is called the vertex of the angle. The rays are the sides of the angle. There are lots of ways that we can name the same angle, and so we're going to name this angle on the screen in several different ways. Well, first of all, we could name this angle E. And that's because E is the vertex of that angle, and because this angle isn't connected to any other angles. There can be no discrepancy. We know that angle E is what it is. Another way to name this angle is by saying angle DEF, and that's because, well, if you had connecting angles, naming with three letters is crucial so that you know exactly which angle you're talking about. But notice that the vertex is in the center of those three letters, which means we could also name this angle FED. The fourth way that we could name this angle is by the number that is in the vertex of that angle, so we could also call this angle 1. At this point, please go to your math book online and watch the video in Lesson 16.2, Concept 2. The distance around a circular arc is undefined until a measurement unit is chosen. Degrees are a common measurement unit for circular arcs. There are 360 degrees in a circle, so an angle that measures 1 degree is 1/360th of a circle. The measure of an angle is written the measure of angle A or the measure of angle PQR, using the lowercase letter m right in front of the angle symbol to notate that we're looking at a measure of an angle. There are 4 classifications for angles. There's the straight angle that measures 180 degrees. There is the obtuse angle. That measure is somewhere in between 90 and 180 degrees. An angle whose measure is exactly 90 degrees is called a right angle. And then an acute angle is an angle that measures in between 0 and 90 degrees. Again, at this point, go to your math book online and watch the video in Lesson 16.2, Concept 3. In this example, we're going to find the measure of angle AXC using the figure below. Now notice the letter X is in the center of those 3 letters. That means X should be the vertex, and if we look at the protractor, we definitely see that X is the vertex of all of the angles, which means we can't just call any of these angles angle X. There are too many connected to it. We have to call them angle AXB or angle BXD or something similar, but X has to be in the middle. If we're going to find the measure of AXC using the figure below, angle AXC is in this location. Okay, so we're looking at how wide, how big that angle is in degrees. Since our angle starts with ray XA, okay, this is ray XA, we're going to start on the outside of the protractor with the outer numbers moving this direction. And if we look at where C is, angle AXC actually passes right through 70 degrees. And so the measure of angle AXC is 70 degrees. Let's find a couple more angles on this while we're at it. Let's try and find the measure of angle AXE. Again, ray XA starts us on the outside of the protractor, and this time we're going to follow it all the way around to the point E. So we're looking at how wide this angle is on the outside of the protractor. If we look at where ray XE meets the protractor, it looks like it passes through pretty close to exactly 150 degrees. So angle AXE, the measure of angle AXE is 150 degrees. One more. Let's find the measure of angle FXD. Now this time we're talking about this ray and how wide it is when we connect it to this ray. So what the angle of FXD is. Now this time, since we're starting with ray XF, we're actually going to work on the inside of the protractor where the 0 is. And if we follow it out from the inside, we're looking at the inside numbers, it looks like, let me erase my marks, it looks like XD passes right through 65 degrees. Right here, in between 70 and 60 at 65 degrees. So the measure of angle FXD is 65 degrees. An angle bisector is a ray that divides an angle into two angles that both have the same measure. And in this figure, BD bisects angle ABC, so that angle ABD is the same, it's the measure of ABD is congruent, it's the same measure as angle DBC, which is what these little marks mean right here. Since these angles both have one mark, those angles are described as being congruent. They both have one mark. If they were different, we would mark one of them with a second set, but they're not. They're exactly the same. These two angles are the same because BD bisects that angle. And then the angle addition postulate. If you look at the diagram, it says if S is on the interior of PQR, in other words, S sits somewhere inside or in between the two rays in the angle PQR, then the measure of angle PQR is congruent to PQS, that's this angle, plus the measure of angle SQR, that's this angle. So let's use this diagram to find the measure of PQR. If the measure of PQS is 82 degrees, and the measure of SQR is 28 degrees. By the angle addition postulate, we should just be able to add 82 and 28. We add those together, we get 110 degrees, which means that the measure of angle PQR equals 110 degrees. In this diagram, ZY bisects angle XZW. What we know here is that the measure of XZY is 7x plus 1 degrees, and angle YZW is 5x plus 11 degrees. Now in the beginning it said that ZY bisects these angles, which means that these two angles that are connected by ZY are congruent. They are the same size. And so what we can do to find the measure of the angle, well, we first have to find the value of x. And since those two angles are congruent, I can set angle XZY equal to angle YZW, and then solve the equation. So to do that, I'm going to subtract 5x on both sides to get all the x's to one side, and I'm also going to subtract 1 on both sides at the same time. 7x minus 5x makes 2x. These cancel. 11 minus 1 is 10, and so x is equal to 5. But that's not the answer to the problem. All we know now is the value of x. What we really need to know is how big those angles are. So I'm going to substitute the value of x into the expression 7x plus 1. I'm going to put the 5 right here. And that means 35 plus 1 is 36 degrees. So I can replace the expressions now. X, Z, Y is 36 degrees. And since we know they are supposed to be congruent, this one is also 36 degrees. The original question wants us to find the measure of X, Z, W. That's the whole thing. So the final step to finding that angle measure is to use the angle addition postulate and add those two angles together. And so together, the measure of angle XZW is 72 degrees.